this video, I'm going to talk about prior knowledge that you would need for doing simultaneous equations. So there are usually three ways that we represent any linear relationship or linear equation. The first one is the standard form. So if your equation is written in the format of ax plus by and you leave your intercept or the constant value to the right, it's not an intercept, it's a constant value, then that's a standard form. But if you equate that linear equation ax plus by minus c equals to 0, we treat that as general form. And then most popular one is gradient intercept or slope intercept form of a line, which is y equals mx plus c, where m represents your gradient and c represents y intercept. Again, by now you all should know what a gradient and an intercept and an x-intercept are. Gradient tells us the rate of change, the as x increases, what is the change in y, and that is very consistent. That's why we can pick any 2 points on a line, and if you do rise over run, it have to be the same. Okay, so that's why we call gradient as slope, rate of change, per unit value. So these are all synonyms for that. And then there are different formulas that we can use. One is y2 minus y1 over x2 minus x1. So, but all these are done in a different video, so please check that out. But today's focus is how do you quickly plot a line. To plot a line or a linear line on a graph or a coordinate plane, you need only 2 points. You need 2 coordinate points to connect them and make a line. So the quickest way is whenever an equation is given to you, find the x-intercept and the y-intercept. That's it. So I'm going to show you here. So the original equation is negative 2x plus y equals 4. Now, if they give you this equation, we need to know there are only one rules to remember for x and y intercept. X-intercept is nothing but it's a point where your line touches the x-axis. And at that point, your y is 0. So what you're going to do, you're going to set y to 0. So negative 2x plus 0 equals 4, right? Then you divide both sides with negative 2 and your x is negative 2 comma 0. So negative 2 comma 0 is right here. So this is what your x-intercept is. Then for y-intercept, you need to set x to 0. It's the opposites. Because a point on y-axis, there should be a y value, but no x value, because x is touching always at this origin 0. That's why all the x values on this y-axis are 0. So when you set x to 0, negative 2 times 0, this entire piece becomes 0. So your y is equal to 4. But when you're writing the intercept as a coordinate point, you clearly have to show 0 comma 4. Plot that point, and then all you have to do is connect those two dots, and there is your line. So this is the graphical way quickly to show your equation. Now I have done an extra piece. If they ask you to find gradient as well, so you just have to do this extra piece. So negative 2x plus y equals 4. Put positive 2x, positive 2x, so they can get rid of this. Then you have y equals 2x plus 4. This can be easily compared with y equals mx plus c. So in the spot of m, you have 2. So therefore, your gradient is 2. So this is a quick analysis of linear equation. Thank you guys. Thanks for watching. All right. Let me show you the applications of linear equations for simultaneous situation models. So simultaneous means more than one equation you're going to use. And so in this case, you have two linear equations and you're trying to solve, because we are treating these two together, we call them simultaneous, by substitution or replacing technique. So the gist that I just showed you up here, this is like a prior knowledge, quickly able to understand what a linear relationship is, what x and y intercepts are. Now, when you are given two equations, these two equations, if they are intersecting lines, they have to intersect at only one point, and that point is called point of intersection or your solution. Now, the speciality of that point is that point is the only common point in both of these equations. So they both should have the same x and same y at that particular location, because that's how they both are intersecting at that common point. Now, how do you do with substitution? So this one is the simplest form of solving. So both equations, I'm naming them as equation 1 and equation 2. So equation 1 is given to you as y equals 4x minus 7, and the second equation is given to you as y equals 11 minus 2x. So now, when you know that you're trying to find the solution, you can clearly say that since x and y, both of them are equal for each other, we are going to equal equation 1 to equation 2. So what are you trying to do is you're eliminating the y and you're bringing in x and x on both sides of the equation, so you can easily solve for x using our algebra rules. So to solve this, again, how to solve equations, algebraic expressions, or simplifying algebraic expressions and equations, that is an entire set of videos that I've done. You can watch that. But the 5 golden rules that I keep emphasizing: bring letters to the left, move numbers to the right. Whenever you're swapping things across the equal sign, remember to change the sign. Whatever you do on one side, you got to do it to the other, and then isolate your variable at the end. So that's what I did. And then once you get your x value here, you take this x value and you substitute equation 1 or equation 2. It doesn't really matter, based on your convenience and simplicity of the equation. To approach the solution faster, you have to make that decision. I'm choosing equation 1. So 4 times x, replace x with 3 minus 7. So your y is 5. Therefore, the solution is 3 comma 5. So this is the common point for both of the equations. Thank you, guys. Please check out other videos on more complex simultaneous equations that I have posted, and also look out for some applications that we use in real life, applying math modeling to make decisions regards to money or best buy analysis. Thanks, guys. Thanks for watching. Bye bye, and have a blessed day.